are three pieces marked on these two triangles. But right now, what are the two theorems that we have talked about? Yesterday we did what? Side, side, side. We just talked about it, right? Side, side, side. What was the one that we talked about last week that was on the quiz? Side, angle, side. Okay? So right now, the only two ways that we can prove triangles congruent are these two methods, these two theorems. Okay? Eventually, when we get through the chapter, we'll have 5 different ways of proving triangles congruent. Okay? Right now, we only know 2 of them. Okay? So eventually, maybe we could prove these 2, but we can only use what we know for right now. Okay? So, in order to do side, 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 I need to know all 3 sides are congruent. Do we have all 3 sides are marked? No, right? We have 2 pairs of sides marked. Right now, I don't know if AC and DF are congruent. And there's no way to prove AC and DF are congruent. Okay? So we got to be able to prove that somehow, some way. We do have an angle, but why does that angle not help us here? Where would this angle have to be in order to be side angle side? It'd have to be E and it'd have to be B, right? It'd have to be between the 2 sides that we're given. And so, yes, we do have an angle. It kind of looks like side angle side, but the angle must be between the 2 sides. Okay, that is a must. So that's what we would have to have, and that is not working here. Okay, so we got to be careful of that. Today, we're adding a new one. This one's a little bit different than the others. Okay, the others have 3 letters that we use. This one only has 2 letters that we use, but it still has to have 3 pieces. The reason we don't have 3 letters here is in order to use the hypotenuse leg theorem, from here on out, I will call this the HL theorem. And you don't have to write, so that way you don't have to write out hypotenuse leg every time. HL is hypotenuse leg, okay? The 3 things that we must have a 90-degree angle. So we have to have a right angle, okay? And we have to have a pair of legs, and we have to have a hypotenuse that's congruent. I'm going to show you a picture here in just a second. But first of all, it has to be a right triangle, okay? In a right triangle, the 2 sides that touch the 90-degree angle are called the legs of that triangle, okay? So a leg is going to touch the 90-degree angle. The hypotenuse is going to be opposite the 90-degree angle. The hypotenuse is also the longest of the 3 sides. Sometimes that's easy to tell, sometimes it may not. But it is easy to tell that it's across or opposite. So the hypotenuse does not touch the 90-degree angle. It's opposite. It's across from it, however you want to say it. Okay? That's how I know the difference between a leg and a hypotenuse. In order to prove 2 triangles are congruent, using this theorem, if I have a right triangle here and a right triangle here, okay, the right angle has to be one of my 3 pieces. So I can only use this theorem if I have a right triangle. The right triangle must be one of my 3, okay? That's why it's not in the name, because it has to be a right triangle. The other triangles that we did the last couple of days, they didn't have to be a right triangle, okay? This one must be a right triangle. That's why I underlined a right triangle right here, okay? Or right angle. I can mark these 2 as being congruent. These 2 would be the legs. And then I could mark these 2 as being congruent. And these 2 would be the hypotenuse. Okay. So this then would be hypotenuse leg, because we have 2 pieces that are congruent plus a 90-degree angle. And so we call this the HL theorem. We would say these 2 triangles are congruent because of the HL theorem. So it's a new theorem, okay? So we now have 3 ways to prove triangles congruent. Eventually, we're going to start seeing proofs that are just going to say prove it. And like today, it's kind of nice because we're only focused on HL, right? And we know that the proofs that we're going to see are going to be the HL theorem. But eventually, all of these could be in play. We could use any of these theorems when we try to prove triangles congruent. And that's going to be the part that gets to be a little bit harder as we go. All right, here we go. Here's another proof. And they set it up as a 2-column proof. The first thing that I would say here is redraw the 2 triangles. I think you're going to have a lot more success here if you were to redraw these 2. Mainly because these 2 are overlapping one another. So this is W, Y, Z, and this one is X, Z, Y. Those are the 2 triangles that we are trying to prove congruent, and it tells me that right here. W, Y, Z and X, Z, Y must be congruent. Okay, they give us some information here. Given W, Y is congruent to XZ. The first thing that you have to do here, okay, and if you're going to be successful with proofs, drawing a picture is a big deal, and then marking the pictures with the information that we know is a huge deal as well, okay? Because I got to know how many pieces do I have, and do I have enough to prove my triangle congruent. Right now, we don't have anything marked, okay? So WY and XZ are congruent. It gives me that information, so I'm marking it, okay? Make sure you mark the correct sides. It also tells me that WZ, what's the upside down T mean? Perpendicular. WZ is perpendicular to ZY, and XY is perpendicular to ZY. That's my given information. Okay, so we know the symbol for perpendicular, okay? What does it mean to be perpendicular? If we were going to do the slopes of it, yeah, but we don't have to worry about the slopes of it. You're on the right track if we were going to focus on the slopes. But if 2 lines are perpendicular, what does that mean that they form? 90-degree angle, yeah. Okay, so here's what I can say. Angle Z and angle Y equal 90 degrees. And I'm only using one letter here because I separated the triangles. And because there's 2 angle Z's, you probably want to go WZY. That would be better. So if I was going to do this correctly, I probably should say WZY so we know which Z we're talking about. And angle XYZ equal 90 because there are 2 Y's and 2 Z's. Okay, how do we know that? What would be our reasoning for why those are 90? What does this symbol mean? Perpendicular. And what does it mean to be perpendicular? 2 lines form a 90-degree angle. So when I say, what is perpendicular, and you tell me what it means to be perpendicular, what are we doing? We're given the definition of perpendicular, right? We're defining what it means to be perpendicular. I know what perpendicular means because of the definition of perpendicular. Hey, how many pieces do we need? 3. How many pieces do we have? 2. Okay, I need one more piece. And it's got to be, right now, would this side here be a hypotenuse or a leg? It's going to be the hypotenuse. How do we know that this side here on both triangles is the hypotenuse? It's opposite the 90. It does not touch the 90. So this is the hypotenuse, and this is the hypotenuse. And for today, I'm going to mark that with an H because I know that I need the hypotenuse today, okay? So I also need a leg. are there any legs that we can prove congruent here? Okay, and this looks a little different than ones that we've seen, but ZY here and ZY here, when I look at the original picture, what's happened? They're exactly the same, right? They're sharing that side. Those two triangles are sharing this side. So what do we say in that situation? ZY is congruent to ZY. Because of reflexive property. If those two things are exactly the same, then it is the reflexive property. Okay? So I'm going to mark it. And this is a leg. Do we have three pieces? Yep. And the three pieces we need are a 90-degree angle, the hypotenuse, and a leg. Okay? So my final statement, remember that we're just going to take this proof statement and we're going to move it right down here. And this will be my final step. Triangle WYZ is congruent to triangle XZY by the HL. And that's our proof. Okay, questions on any of those steps? Okay, do we still need three pieces today? That's the part that's holding true, right? Three pieces is what we need to prove triangles congruent. It's just different kinds of pieces. We couldn't do side, side, side here, right? Because we don't have three sides. We can't do side, angle, side because this is not the angle between the two sides. This would be side, angle, side right here. Okay, this would be the angle I needed. So side, 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 and side, angle, side would not work here. So I'm just telling you that. Like, that's why we need more theorems, is because you can't do side, 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 or side, angle, side, and those are the only two ways right now that we can do it. So now this is a third way that we can prove triangles are congruent. Okay, let's jump over here. The television antenna is perpendicular to the plane containing points B, C, D, and E. Each of the cables running from the top of the antenna has the same length. Prove that triangle AEB, AEC, and AED are congruent, okay? All three of these are congruent because we want all of those cables to be the same length, right? I mean, we could probably make them different lengths, but we're trying to do it and keep it as sturdy as possible. Otherwise, if you have one that's a little bit longer, maybe it pulls the tower and makes it lean a little bit. We don't really want that, right? So we want all of these to be the same so it keeps the tower upright. You don't necessarily have to draw all three of these, but I'm going to go ahead and do that just so we can kind of see what's going on here. And this is a little bit different because we're proving all three triangles are congruent here. Okay, so this one's going to be A, E, B, A, E, C, and then A, E, D. B, C, and D are the 3 points where it's tethered to the ground. Fixed point where you're going to tie that cable to it. AE is the post, the middle of the tower. Okay, we're going to restate all of our given information. AE is perpendicular to EB. AE is perpendicular to EC. AE is perpendicular to ED. Okay, I'm putting all of this in one statement here. This is a lot of information for one statement. If you want to make two separate statements, you can, but I think it's easiest just to put it all in one. Okay, now we want to mark this. AB, AC, and AD are all congruent. So I go ahead and mark those three sides. What does all three of these statements tell me? That they're perpendicular. And once again, just like we did on the last one, the fact that they're perpendicular tells me what? -90-degree angles, okay? So we're going to say angle AEB, angle AEC, and angle AED all equal 90 degrees. Okay, what's my reasoning? Definition of perpendicular. We know what it means to be perpendicular because of the definition of perpendicular. I know I'm kind of running into the next problem here, but should have probably zoomed it in a little bit. What else do we know about, and let me go ahead and mark all of those. Right now we have two pieces, right? We got, what side would this be? Would it be a hypotenuse or would it be a leg? It's the hypotenuse. So this is the hypotenuse on all three. We have a 90-degree angle on all three. So we now need to prove a leg is congruent, okay? Is there a leg on all three of those triangles that would be congruent? AE, right? AE is the same side on all three of those triangles. So I'm going to say AE is congruent to AE is congruent to AE. Because you have an AE on all three sides. Okay, our reasoning there would be reflexive. Okay, and then finally, step 4, we're going to rewrite it just like it is up there at the beginning of the problem where it says prove. This one's a little bit weird because it's asking me to prove 3 triangles congruent instead of 2, but it's still the same idea. And then HL is our reasoning. Okay, on this one here, we're not going to necessarily write a 2-column proof. If you want to, you can, but if it doesn't say to write a proof, then you can do it, but you have to do it in like some statements or sentences, okay? It doesn't necessarily have to be a full sentence, but you got to kind of have some statements. This is what I know. This is what I am missing or need to add to the mix, okay? The other thing that I would say here is I would redraw these 2 triangles the same way. So this one is BCD. Okay. What I would do is I would flip the other one so that they look the same way. B is the 90-degree angle. And then we want C, and then we want A. Okay, we know that AC and BD are congruent because they're already marked. What other piece of information do these 2 triangles share? Ryan? Oh, yep, I forgot the 90 degree. Thank you. Okay, so they both have that, okay? Hey, now as I look at the original picture, what do those 2 triangles have in common? BC, yeah. Okay, so here we would say BC is congruent to BC by the reflexive property. Okay, this is a leg, this is the hypotenuse, and we have a 90-degree angle. Okay, so do we have enough to do the HL theorem? Yeah, we got our three pieces, right? So we're going to say triangle ABC is congruent to triangle DCB. Notice once again, I'm just copying this right back down, okay? I'm not making up my own statement. I mean, you can if you want to, but don't make it harder than you need to. Just copy down the statement that they're telling me that we're trying to prove, and we would say those two are congruent because of HL. All right, let's look at the next page. Look at those two and try to determine if those triangles are congruent, and if so, why. And you can use any of the theorems that we've used up to this point, okay? I'm also going to add another one to the mix here. Okay, look at them, and the three that we have now talked about are side angle side, side side side, and the HL. Can I use any of those three to prove the triangles are congruent? I'll give you a couple minutes to take a look at all three of these. All right, let's start with this one. Are there any angles I can prove on this triangle, or pair of triangles, Ryan?
Could you do like CWY and FW?
How come?
Because it splits the middle because the WX and WZ are the same, so that'd be the bisector. WY would be the bisector one.
Maybe, okay, but we don't quite have enough information to know that for sure, okay? It's good thinking, yeah, and it might be that way, but we would, in that case, we would need a statement that says WY is the bisector of that angle. Okay. Anybody else? Any angles? Anybody get any angles that are congruent here? What about X and Z? Can we say X and Z are 90? Oh, looks like they might be, but we don't know that for sure, right? So it's another thing that kind of looks like it, but we can't just assume. So are there any angles that we can prove here? Yeah, a side, yep. Okay, we do know that WY and WY are congruent, okay, on those two triangles. So I can say WY is congruent to WY by the reflexive property. Okay, and so therefore, these two triangles are congruent because of side, side, side. So side, side, side would be our theorem here. Okay. This one over here. This triangle has 3 pieces. This one only has 2. Okay, can we do side angle side? So first of all, is this angle between the 2 sides? No. So that pretty much tells us side angle side is out. Okay, is there any way to prove that this side and this side are congruent? No. If I told you that C was the midpoint of EB, then I could do that, right? But we can't just look at it and say, yep, looks like CE and BC are congruent, so we're going to go ahead and say they're congruent. We need something to kind of go through it, kind of like we were talking about with the angle with the bisector here a few minutes ago, okay? So it looks like they could be, but we just can't assume that they are based on what we know, okay? But what would be one thing that we could assume or know, Berkeley? C is the midpoint of A and D, and we know that, and they're already marked, okay? So, because it's already marked, we don't necessarily have to make a statement for it. Cora?
Angle ECD is the same as ACB because of vertical angle components.
Perfect. Angle ECD equals 90 degrees, okay, by vertical angles. Those two are vertical, they're across from one another, okay? Now, as I look at this, we have to decide which theorem we're going to use. Okay, so let's go by process of elimination. Can we do side angle side? Nope, angle's not between the 2 sides. Do I know all 3 sides? Nope, we don't have anything marked here and here, right? So we can't do side, side, side. So the only one we have left is HL, okay? And what do we need for HL? Well, we need a 90-degree angle. Boom, okay? This side right here is my leg, and this side here is my hypotenuse. So we would say these two are congruent because of the HL theorem. Okay, questions on that one? All right, let's look at this last one here that I put up here. Okay, let's think about the ones that we've done so far. Okay, the first one that we did last week was side angle side. Can I do side angle side on this one? Do we have, how many pieces do I have on these 2 triangles? How many does this triangle have? 3. How many does this one have? 3. Okay. Now, in order to be side angle side, the angle has to be between the 2 sides. Is the angle between the 2 sides? Yeah, just follow the path, right? Side, angle, side. The angle's between those 2. And so right now, as it's marked, we're good, okay? Now, I gave you this one on purpose because could we do side, side, side here? Yeah, because what do we know about that middle side? Yeah, it's a shared side, right? So that's a reflexive property. So I could also do side, side, side. Could I do the HL theorem? Yeah, because this is a 90, this is a leg, and this would be the hypotenuse of those 2 because it's opposite the 90. Here's the 90, here's the hypotenuse. Here's the 90, here's the hypotenuse. So this one, you could do any of the 3. So on a quiz or a test, do you have to name all 3? No, just give me one of them, right? So the reason I show you this is because on some of these triangles, there's going to be more than one way you can do it. This one had all 3 that you could do, okay? And you just have to pick one. But you have to show me, you have to prove, you have to say this is enough. Now, if it was me, based on the information I was given to begin with, I probably would have just gone side angle side because that was the easiest. But you could do the other 2 as well. Okay.